Kick record. All right, so we are recording. Well, welcome, gentlemen, and whoever to the to the August meeting of the Seattle Robotics Society. We are glad that so many, anybody that can come, always glad to have them. We are glad we're able to continue to do this virtually. I'm looking forward to the day when we can all see each other's smiling faces, in person. So hopefully that won't be too far out there. Our government tends to try to make that difficult as possible for us. So we'll see what happens. We're currently recording meetings and posting them on our YouTube channel. So you can actually search for them in, let's see, if you search for SRS clips and notes, I believe is what how Donna has that in there. So you can I'll respond to that in just a second, James. So there is a YouTube channel. I think if you look that up, I believe if you look up SRS clips, I believe you will find the YouTube channel. But I try to I'll put a link in the weblog after the meeting to point you there directly. So and you can find past meetings back there as well. So we are planning to try to continue to have both the virtual, even when we get back to in person, that we will have these meetings online. I will talk about that in a second. Oh, there it is, clips and more. I'm sorry, that's what it is, SRS clips and more. So because as we've discovered, there's lots of people from all over the place that have been joining us, and it's very cool to have this ability to plug into folks all over the country. So I think keeping that going is definitely going to be a priority. Let's see. Oh, just a couple of notes there. As you can see on the slide there, if your microphone is on, do mute it, please, unless you're actually sharing. And then put any comments, links, stuff you want to share, just put it in the chat. I have the chat window open here on my monitor so I can see stuff. So if you've got questions and things, feel free to shoot them in there. I'll try to answer them as I can. Follow our standard agenda. Slide here that we're talking about that continuing the online meetings in addition to while we're doing in-person meetings. I will probably need assistance at wherever the venue is to maybe have somebody actually run the equipment so that I don't have to I have to think about that and kind of multitask. So I'll be looking for people to help out with that at that time. So and let's see. I've got to get with my son again here and see. He has a website up that's kind of what would you say, what do you call them, a beta, alpha? I think we call this an alpha. So it's we need to update some more of the content to get it ready for going live. But anyway, it is coming along. It's kind of a slow process, but it's happening, and hopefully we will be able to get that up here in the not too distant future. Today we're not having a formal presenter today because we are going to join the Dallas Personal Robotics Group and the RoboColumbus competition, which should be happening today. I actually say, Lloyd, could you plug into that and just see kind of where they're at? And
let me see if I still got the link for it.
Yeah, I believe if you just Google RoboColumbus, I think it will come up, or DPRG RoboColumbus. And just I'm just kind of curious because they started the kind of the preliminary stuff for their contest, I think an hour or two ago. And the 10:30 is kind of the time frame when they were actually planning to start the competition itself. So, if anything, they might be kind of in the middle of still sort of doing the qualification and that sort of thing. So, Anyway, our plan is to just tune into that and see where they're going. Yeah, that's the link there. So the link has just been posted into the chat.
Oh, cool. Thank you.
Anybody who is curious can go ahead and pull that up, and you can have that sitting off on the side. Just be sure you're muted so that it doesn't come through.
Can you hear now?
So are you? I heard it sounded like somebody was connected there. So they're doing.
I'm trying to see if I could find the link to the video for the.
Yeah, they're doing. Yeah, it should be. It's on that page. It's a Google Meet.
There it is.
So they're. This will be kind of interesting to see how this sort of works to splice this together. So we'll see what happens. But I'll let you kind of just mess around with that for the time being. I will move on here. Presentations. I actually have a great lineup. Robert Kellogg has been very helpful in providing suggestions, and we've gotten lots of cool potential presenters coming down the pike. In red on the slide there, you'll see next February we are going to have a special late afternoon meeting, and I'll talk about this every month up until then. The presenter is actually going to be presenting live from Japan, and in order to put his presentation time not in the middle of his night, we need to shift our meeting time forward to accommodate that. So they're 16 hours ahead of us there. So it's a pretty kind of a major shift, but this puts our meeting at like 8 to 10 a.m. his time. So it fits, it's a comfortable time for him to be up and about, and it'll and we'll only do this once. It's on the website as you see it there. So the plan is only to do this when it's necessary to do it. Normally we will have our 10 to noon Pacific time meetings. Normally anyone within the United States, even Hawaii and Alaska, well, extremes of Alaska could potentially be, they could be kind of early for them to do a presentation, but we haven't had anybody from up there yet come asking to present, or I haven't been pointed to anybody. So we'll just deal with that if and when the time comes. And then use the SRS GL to contact me if you have any ideas, suggestions, etc. So here's the lineup of what's coming, and so we are really set. We've got some pretty cool presentations coming down the pike. Some of these people are actually CEOs of their own robot companies, and so it'll be kind of fun to chat with them. And if there's a few of you have ever tried to start a robotics company, it's a really hard way to make a living, very competitive, and very challenging, but there are people out there doing it, so we'll have an opportunity to meet those folks and chat with them and ask them questions. So anyway, we're right now, the facilitated discussion is a kind of a placeholder. I may end up replacing that with another presenter as I continue to work out here. So I use those as kind of fillers in case a presenter can't make it, or I just can't find anybody for a particular slot. So those tend to move around, but the presenters themselves should be pretty solid. So and the Robothon committee, we had a meeting this last Thursday, and talking about the upcoming exhibition event, and I'm going to turn it over to Lloyd to share the details about what we talked about and what's happening.
Yeah, so we're going to do, well, we called the first event a pretty good success. Looks like everything went pretty well, and so far as we heard, everybody was pretty happy with it. If you have comments or suggestions on how we could do that better, please, just let us know. This was kind of an experiment to see how this would go, and it seems to work pretty well. As many of you know, we did have more presenters for the first event than we actually had space for. So we're going to do a second event on November 13th. We still have presenter slots open. So one thing we did change, we're going to lock the format down a little bit. We're going to have 3 presenters of 15 minutes each, roughly, and then a break, and then 3 more presenters. So rather than, we were kind of shooting for 8 the first time, and we ended up with 5, and we kind of settled on 6 seems to be a good sweet spot. So we're going to do that. So we're going to keep running these as long as we have presenters. But it'll be basically the same thing we did the first time. If anybody wants to see what we did the first time, the video is posted. So you can go over to the site that Steve had in the slides earlier and pick up that event. So we do record them. If you're interested in presenting, please feel free to let Donna know or myself, and I'll forward it to Donna. And we'll see you on November 13th for the second event.
Cool. Thank you, Lloyd.
Oh, and I'm just going to mention one more thing. Just it should be probably pretty obvious to everybody at this point. We are not doing a full-on Robothon this year. So we're going to continue to just do the remote events. So no in-person Robothon this year. Okay, now I'm done.
Okay, so let's see. Joel Buss, will all this info be available offline? Yes, as far as what Lloyd just talked about, I'll probably just kind of grab and edit the info that he emailed to me, and that'll be part of the notes. So the details of the actual Robothon event, though, will be updated on the site. I just checked it this morning. Donna hadn't updated it yet, so
okay.
It's still talking about mid-October for the event, because that was the last month when we were talking about it. That's kind of what we thought might happen, and last Thursday we agreed that November was better because of other things happening in October. So do look at that, and the SRS clips and more. The video is there, so you can go ahead and watch it. It's about 2.5, 2 3/4 hours long or so, but you can skip ahead pretty easily to just kind of get a flavor of the presentations, a wide variety of things, and if anybody has contacts with other clubs out there, do by all means reach out to them and say, hey, anybody interested, consider presenting online at this event, because we would love to hear from robotics folks all over. This is and I know we've got plenty. I'm sure we've got plenty of people here, but I know some of you are maybe a little afraid or intimidated by being in front of the camera and presenting, but this is a pretty friendly audience. They don't, you don't get too many cat calls. So it's a fun group, and it goes quick. I mean, it's 15 to 20 minutes is a tight time frame for presenting, and you'd be surprised how fast that'll fly by. So anyway, do keep that in mind, and hey, sign up for it. And by all means, if we fill it up, we'll just keep projecting more of them out there. So don't be afraid to put your name in the hat and see what happens. Let's see. So after the meeting, so I don't. This is probably don't really know exactly how this will play out today. Depending on the DPRG's contest and stuff. I think the intent is that, this meeting can go on as long as you want. It doesn't, and you can continue watching, or you can plug in if you're, if you want to just go directly to their to their site and log in that way. You're welcome to do that as well. But let's see, snapshots of prior in-person events. Okay. Oh yeah, cool. Thank you. Does this count academia work as well, Brian? Okay. Let's see, that is that having to do with having like university professors and such presenting? I'm not sure I understand the question. Okay. Yeah. You can. We haven't been recording meetings for that long, unfortunately. So there's a lot of things from the past. But if you go to on the sidebar on the main SRS web page, there's past presentations, and you can click on that link, and that will take you, and you can get to the slides from previous presentations and see what's been done. And we've had, we've had hundreds, literally. So that goes back years. So, now we will actually have video, and for the most part, unless the presenter does not wish us to record their presentation, which so far has not been a problem, our intent is to do that and have them available for you. So there, okay. Yeah. Okay. So let's see. Okay. So I've wanted to make this, go quick so that we get to this point. Unless somebody else has anything they can think of, we can go ahead, and anybody has anything they would like to share, projects they're working on, challenges that they have, questions about the club, questions for any particular members. And you're free to unmute and go ahead and ask your questions at this point. Appreciate identifying yourself so we know who you are.
Hello, can you hear me?
Yeah.
Hi, sorry. So it's actually, the name is listed under Joel, but my computer for some reason wasn't allowing me to connect through the Zoom. This is Erica Herrera. So
Okay.
I'm wondering, so we're from Washington out in Seattle.
Yeah.
But I just saw that there was a robotics meeting, so I was like, oh, this is cool. So I have built something with Simple IDE. Do you guys do any type of, have you heard of Simple IDE?
I have not. Anybody else?
Have you heard of Parallax?
Yeah.
Okay. So I built a robot with Parallax.
Okay. Okay.
And I was just wondering, do you guys go over any types of compilers or anything like that? What does a presentation typically look like?
Oh yeah. Wow. Just about. Yeah, we're kind of open to just about anything in the developer space, in hardware development, software development, putting things together. The biggest challenge with building robots, of course, is making a bunch of different complicated things play nicely together. That's a challenge that we all struggle with, I think. So we do. People will present options. Ways to build robots. Let me see. I'm going to roll back on my on the slides here. If you look at under, let's see, January, for example, Myro Volmi, he has printed basically a Mars rover, a 3D printable Mars rover, and he's going to talk about the whole process of basically creating that. What kind of controller he's using, as well as the software and how you put it together. And then we've also had presentations from Ross, Robot Operating System, and a number of presenters that have talked about that.
Has anybody worked with VR at all?
Yeah, we've had folks doing that. Let's see.
That's my space, just to let you in.
I'm trying to think if we've had anybody recently who's talked about that, but that's we've had presentations on that topic, and those were always fun. It was much more fun in person when they could bring equipment and set it up, so we could actually people could try it out.
Yeah, that'd be something I would like to be curious in presenting on, because I build virtual environments. So that could be something that could be really fun to tie into, and maybe just have a live projection of somebody trying the experience, and then also the simulation of what it looks like.
Sure.
Do we do any group projects or anything like that?
Well, we've talked about that on and off. We don't currently have a physical venue. We shared First Washington's warehouse space up until COVID shut things down, and then they jettisoned that because they weren't using it and it got too expensive to hang onto it. They're expecting to lease a new facility sometime this fall, and we're hoping then to be able to piggyback on that and then get back to physical meetings in in that space, but we don't know exactly where that will be, but we're expecting south of Seattle somewhere. So think somewhere maybe between Tacoma and north, or southern Seattle, I guess. That probably somewhere in that vicinity.
Okay, yeah, I would love to be a part of that. So when you guys get further information on that, yeah, I'd love to know. Okay,
well, it'll be on the website when we know details. At this point, like I say, we don't know yet. We've been they'll let us know when something solid happens. So, all right. Let's see. Anybody else out there?
This is Dick. I've got a couple of things to show.
So I was going to just make let me see. So Dick, you are actually upside down. I think you're, I mean, that's really awesome, but it's like it's messing with some of our brains here. So.
Well, let me see if I can, I was trying to fix a problem. My video is really messed up. And
why don't when you could go ahead and share, that would be okay, thanks, Lloyd. I'll take a look.
Where's the share on this?
Let's see. I'm going to go ahead and stop sharing my screen. Okay, so all right. Yeah, so are you go ahead and just do you know how to do that? You just usually kind of slide your mouse down to the bottom of your screen, and then you should see a green square that says share underneath it.
Oh, yeah, okay, I see it.
Yeah. And then just pick whatever it is you want to share and go ahead and do it.
I was going to share something on the video first. Can you see this? Batteries?
Yeah.
Is that the top or the bottom? Okay, I'm moving down to the bottom.
Let's see. Okay, you're kind of right in the middle of your screen there, other than the fact that you're upside down. So I think your camera. How do you have your camera oriented there?
Well, it's built into that laptop.
Huh. Okay.
So anyway, it doesn't really matter that it's going to be upside down. So the other. So you saw the battery.
Yes. Yes.
Now I'll show you what it hooks to. Okay, this is the electronics that it hooks to. Can you see that?
Looks like it's on a hat.
Yeah, it's on a hat.
Yeah.
So if I put it on my head, it looks like this. Now the other part of that is a heater. And next to that, the small thing is a temperature sensor. So the purpose of the electronics is to control the temperature. And this will go inside my mask like this and keep my nose warm in the winter. Does that make any sense?
Yeah, nose warmer.
Yeah. So it's just temperature control. There's a little adjustment here to set the temperature. So that's my current project. And it's just about done.
That is
I haven't finished the mounting of the heater and the mask. Now there's another piece of this. There's an optional piece, and it consists of a couple of parts. This is a TC view right here where my finger is pointing. So it's a small OLED graphic display. And the purpose of this, it will connect to the mask heater to show what the temperature is and other information too. Well, there'll be communication between this and the mask heater. And I can't really demo this without better video, but there's an encoder here. You see this? I don't know if you can see this knob my finger is pointing to.
Okay.
It's a Quadrature encoder, and I use this to scroll a menu on the display over here. So there's a menu of things you can do, and there's this button here. This encoder knob is also a button, so you can press it to cause an event. Anyway, that's the other part of that project. And and for the communication between the two, that's where I need to share the screen. So I'm going to try that and we'll see how that looks.
Okay.
Let's see. So is that right side up or upside down?
That's actually right side up.
Good. It's a camera problem then.
Yeah.
So this is just an Arduino serial monitor screen. Oops. And the purpose of this little example here, can you see this all right? Can you read it?
So if everybody knows, if you hover on his image and click on the little push pin, that will make his screen fill the bottom of the, or it'll basically full screen his video. So it's tiny. I mean, it's be impossible to read this if he's down as he's just a little thumbnail. So it's a little tight there, Dick. If there's any way you could make that a little bit bigger, that would be helpful.
Well, it's the Arduino serial monitor. I don't.
Okay, not much you can do about it then. Okay.
Well, if you can't see it, I don't know that I can do much with it.
I believe that you can shrink the size of that window. Just make that window smaller on your screen. It'll make it larger for us. Yeah, like that.
There you go. Oh,
Okay,
yeah.
Is that all right?
That's great.
Oh,
Yeah.
okay.
That's great. Okay.
So there's it's just hooked up to an Arduino Uno. And what's showing here is a just a menu of things you can do. And the purpose of this is to demonstrate how I communicate, with other things. So the two things, the mask heater and that separate display thing, is communicating with this type of scheme here. So I'll just pick something here. Suppose I was hooked up to a robot and I want to send a command to turn in place. So I'm going to highlight this from the menu, copy that. Control C. I just put that in. So this is a command. Send that command. It didn't do anything because I got the trace turned off. So I have to turn that on. Yes. So we'll try this again. So I just took the input, which was, so it starts with a pound sign, followed by a list of numbers. So those are the arguments to, say, a function call. And the T on the end just indicates we want to turn in place. If there was an S on the end, it would be for moving us in a straight path, and C for a curve. So you kind of get the idea there, how these commands work. Sorry, I'm losing my voice. So these are the different command examples here. There's no real robot in this particular example. So it doesn't cause any motion or anything, but it just spits back the data. Some other commands you can put in are just a question mark. So it just shows the menu again. There's a P. So that prints out the last argument that Lista was entered. Remember, this is the one I entered. There's the 20, 90, and 1. And the 1 is for counterclockwise rotation, and -1 would be clockwise. So that, need a drink. So this is just illustrates what you can do with this simple communication scheme. If you have two separate processes, they can both send messages back and forth. They just have to have different protocols for encoding. But it's simple, so you can use it on a kind of a minimal processor like Arduino Uno. Before this, I used to use binary packets. And that worked pretty good, except you can't really type commands in like this for testing purposes.
Yeah.
So that's the idea behind this.
Nice. Yeah, our brains don't
I did
think
put a
right.
message on the on our list server a few weeks ago, just mentioning this, and there's a link on there where you can download this stuff and some documentation with it.
Cool.
So anyway, I guess that's it for now.
That's what you got. Okay. Thank you, Dick.
Okay. So how do I switch off my?
So it should, on the top of your screen there should be a stop sharing. See a red button there?
Oh yeah, okay, I see it.
Yeah.
There we go.
Okay. So now you're back. Okay. Yeah. So if I could unpin you, put you back in the lineup there. So I'm still curious about how you got your camera. You got your camera actually upside down on the one that you're using. So.
Well, it's never been like this before, but I when I was starting up Zoom, it said there was an update for Zoom available. So I got the update. And now
That's pretty cool.
So I'll have to see what I have to do to get this straight.
Maybe the problem is that Zoom thinks you're on the other side of the planet, so therefore it flips you over.
Something like that, I guess.
You could look at settings for tablet mode and see if thinks you're on a tablet.
Yeah, maybe it's something like that.
Oh, that's a good point. Is that where would that setting be?
In Windows, just search for tablet in the start menu.
Shift. It was Control Shift 3. There we go. Oh, I didn't want.
Well, I'm still on Windows 7. So-
Okay, well then ignore everything I said.
Yeah,
Oh, well, you're in
maybe that's the problem,
you're in the medieval ages there.
right? Okay. I'm gonna go on mute.
Okay. So when I plugged into DPRG's event there, they were looked like they're still kind of trying to figure things out. They've got a live camera set up, and it's just kind of broadcasting what's happening. So it looks like I haven't when I bring it up, it puts Google Meet on the main screen over the top of Zoom. So I'll have to play around a little bit. I think I should be able to share that, but I'll have to try that. I don't know. Is anybody else on that at the moment? Is any idea whether they have actually started something? Their schedule says they should be kind of getting rolling around now, but I don't know if they've actually done that yet.
Yeah, I've been popping in and out, and
Yeah. Okay.
nothing structured appears to be
Nothing
happening.
structured yet. Okay. Well, we can just kind of keep rolling along here. I was kind of curious. I did a facilitated talk on electric vehicles here, 2 months ago or so, and the big news in the last couple of weeks with regard to EVs has been fires and issues with the batteries, catching on fire, kind of I call it, it's almost like spontaneous combustion. I mean, it's not really, but in a way it looks that way. General Motors with the Bolt, and Hyundai has had some issues with some of their batteries, and let's see, seemed like there was I saw something about the Taycan, but I think that was just kind of a software issue. They said the car would just sort of stop operating. People would be driving along, and all of a sudden the thing just sort of shuts down, and that was kind of weird. But that does sound like a software problem. But I thought it was kind of interesting because I couldn't help but think back to a few years ago when I was still working for Boeing, and we were dealing with that battery pack that Boeing uses for auxiliary purposes that they inside the airplane, the 787 airplane. And we did a just massive amount of testing to try to isolate and figure out what was happening, why was it happening, and how to fix it. And if you've read anything about that, you can go to Wikipedia, and actually Wikipedia has a pretty good summary of what all the fallout of all of that was. But basically they put it inside of a stainless steel box with a vent line going outside the fuselage of the airplane, and put insulating panels between the battery cells, beefed up the actual individual cell testing over in let's see, I'm trying to think of where was that over? It's over in Asia where they make the batteries, and then they test the individual cells much more thoroughly, and then they put them into packs and test the packs. And then if the batteries survive all of that, then they get put into the boxes and sold to the customers. And I haven't heard any more incidents since all of that was put in place, even though it struck me as a kind of a Band-Aid. Basically, we don't know why these things blow up, so we're just going to make it so it barfs on the outside of the airplane. It doesn't cause a fire and blow up on the inside of the airplane. I don't know, but it was apparently effective. It solved the problem. So there's a lot to be said for don't make the fix any more complicated than it needs to be. But
I just want to jump in and say that people really underestimate the damage potential of batteries.
Yes. Yes,
the
I agree.
we just showed a video. We have a regular safety thing at my company. They just showed a video of a bunch of guys working on a robot at NASA or one of the NASA sub-departments or whatever. There was a bunch of guys standing around this robot, and the battery went off on fire about like a couple of minutes after they had left. So they had been standing right next to the robot, on both sides where the fire came out from the battery. But that was, a couple of minutes before the fire took off. If they had not moved away, and it was not like a slow start and then it built to a fire. It just went kaboom. It was amazing. Wow. So this idea of venting so that, if something goes wrong, the flame, will go outside as opposed to inside the vehicle is absolutely critical. I think that what blows me away is not that they applied a Band-Aid fix. That it took them that long to apply a Band-Aid fix. I think for me, I get really excited about this because it comes back to the idea of accepting failure. Like I think one of the biggest problems we have in engineering is that people don't think about failure. Like they're so scared of failure that they just put it completely out of their minds. Where what we should be doing is thinking, how can this go wrong? All the time we should be thinking about how can this go wrong, so that then we have the opportunity to either make it not go wrong or ameliorate the effects when it does inevitably, at some point in time in the future go wrong. Sorry, my little soapbox.
Well, yeah, and of course, well, you can always fix it with software, right?
Yeah, better monitoring of the charge circuit and temperature monitoring, and then like what's the software going to do when the battery starts to cook off?
Exactly.
Fire off an alarm or something. I don't know.
Right. Well, I don't know. If any of you either own the bolts or have read about what, like there was a software update, over-the-air software update that GM pushed that basically limited the maximum charge that you could put into the car. So that was kind of their first. Well, we think this will solve the problem, and I think that it was either 80% or 90% or something like that. It would just cut off. And they were fairly confident of their fix, and then another fire happened. The car was, I think it was parked in somebody's carport, and the thing just all of a sudden caught on fire, and it was like, and it had the fix, and so it was like, well, I guess that wasn't good enough, So, yeah, and it's and think about this too, is that with the rapid charging. I mean, with Tesla has chargers that are up to 350 kilowatts, and people talk about, oh well, you need to be able to charge these cars faster. Well, let's go for 500 kilowatts or 800 kilowatts or 1.5 megawatts or something, and people don't comprehend how much energy that is. If you start jamming hundreds of kilowatts of energy into something the size of a battery on a car, that's an enormous amount of energy. And
it's a bomb.
Yeah,
that's a bomb waiting to go off. Like, people don't think about this.
Right.
Yeah. Hey,
right.
I want to say, Greg is showing something really cool, and I understand that he's going to do a live demo to test this PCB cutter for the very first time. So I'm teasing. He didn't say that. I'm just trying to bug him. Hey, Greg, before you get started, assuming that you are, I noticed you have a printed circuit or a whiteboard there, a breadboard, and I wanted to ask really quick if anybody is aware of a breadboard-centric servo adapter. In other words, like if you want to hook up little RC servos to a breadboard, you either have to do it like using the signal rows, and then you have to run like power ground, and it wastes just a ton of space. You really wish that you could turn the servo adapter sideways and plug it into power ground and then one signal, right? But the gap is wrong between the power bus and the signal section, so you can't. I'm just curious if anybody has ever made a stupid little PCB adapter that changes the spacing on those pins so that you can directly plug in a servo. Anyway.
James, just what I need is one more PC board to throw into my collection for my next JLC PCB.
I'm in the process of laying that board out right now, which is why I asked. So, yeah,
I've never seen one, but it seems like it would be a simple adapter to throw together.
yeah. See, I'm kind of surprised nobody thought of doing that or has wanted to do that before. I did find one that was sort of like that on Tindy, but it isn't really optimized for a whiteboard. Anyway, sorry, I just wanted to throw that out. So you're going to do a live demo, right, and show us that? Getting a
no. Nice try though.
We were talking about things exploding. It seemed like a good segue.
Yeah, excellent. So, Stephen, do we have a few minutes?
Yes, I think you could go ahead and if you've got something to show, please.
So obviously a PC board cutter is not directly related to robotics, but since many of us make PC boards as part of our robot projects, and this was one that I actually just got from JLC. It's got a couple robot-oriented PC boards on it. It's got some breadboarding adapters. It's got a couple boards here for another project. But once I got this, my other modes of cutting PC boards, I didn't want to tear these up. There's a lot of little tabs in between that I need to cut, and I didn't want to mess my boards up. So I thought I need to throw together something that gives me a controlled means of cutting the PC boards. So I kind of threw this together. My goal was to make it out of parts I already had, though I did have to buy the flexible shaft. I chose to go with a flexible shaft because I wanted something that had a very small diameter. I've seen other PC board cutters, but they're always limited by how far they can cut into the PC board because the motor will hang down and interfere with that. So my goal was to make sure that the cutter can pass over the top of the board. So there's enough space under there that if I was cutting a long board and trying to cut it in half. So it's basically just 3 layers of acrylic here, a base layer, this one with the slot in it, and then one to act as a straight edge, and then some 3D printed parts and a couple little slide bearings over some aluminum tubing to allow me to just slide it back and forth. So I'm pleased with that, and we'll find out after this meeting if it was worth all the effort. In terms of robot progress, I'm still working on ARM version 3. I'm trying to develop a driver board for the 5 servo motors that are on there. When I added up all of the pins, all of the I/O that I would need to drive the 5 servos, to sense the position of the joints, to communicate and some other things, it turned out that I needed 40 some I/O ports. I wanted to go with the SAMD21, but all of the SAMD21s I could find are all the 48 pin with I think 38 I/O ports. So I ventured down the path of using the SAMD that's in the 64 pin variant, and have been trying to wrap my head around how to come up with the variant file necessary to be able to program that using the Arduino IDE. One of the reasons that I need so many pins is that the driver that I've chosen to use is the TMC 2226, also known as the TMC 2209. I think they're both identical except for the form factor that they come in. This uses that form factor that we're accustomed to for stepper motor drivers, except these drivers allow you to communicate with them over serial, and they have some other outputs. And so to make the little modules compatible with existing driver boards, they put these little pins going up, and then you have to run jumper wires. Anybody that knows me knows that I hate that idea. So I have to develop my own board so that I can route those circuits on the board as opposed to having wires in the air. But it was funny because also, if you know me, you know that I don't like processors with lots of pins. I like to have lots of processors, each with a few pins. So this has been kind of going down a new path for me. And as I was laying in bed this morning, I finally decided that this was not the right path for me. And instead of trying to get all the functionality onto one processor, I'm going to use two 48-pin processors and have one drive the stepper motors and then have the other one interface with the CAN bus and the other parts of the arm. So that's where I stand now on my robot project.
Cool.
So
right.
if you're using those little stepper motor modules with the pins going up, do they like seriously, everybody's going to connect to that with like a ribbon cable or something up to the top, or?
Well, so those modules, as I mentioned, you can plug those modules into some existing, like 3D printer boards, and they'll use.
It's that standard Polalu.
Yeah. Well, and they'll use other I/O that's on the board elsewhere on the board, and so this is the box that those little modules came in, and they even supply you with some jumper wires.
Okay. So they're
that,
really expecting you to cable into those pins on the top. That's
exactly.
Really I would have thought that they would provide I guess that they didn't want to mechanically go outside the edge. I was thinking of like a break off tab or something like that would go a little bit off the side and down, and then if you didn't want it, you just snap it off and plug it into the regular socket.
Yeah, but you don't know you don't know on any given board what might be in any given direction.
Right. Yeah, it's a good point.
So that's what I'll be. What's that?
I was just saying I'm thinking through the manufacturer's problem there. That's a real problem. Like, how do you solve that when you want to add some extra I/O to a standard without creating a new standard?
Right. Now, if you're familiar with the Polalu module pinout, 3 of the pins are used for setting the micro stepping. And they generally have jumpers underneath this little module so you can set the micro step. They use those pins for some of the other features of this. That's why you see there's these 3 pins sticking up right here. So you take all those jumpers off so that you're not shorting out those pins, and then you can do more advanced things.
But the 2 pins that are on the end, are those the serial interface?
Well, it's a 1-wire serial protocol. The other one is a, I think it's the index. No, I take that back. One of these pins on the side is the 1-wire serial. On the end, one of the pins is index, and the other one is it's labeled diagnostic, but this particular TMC driver has the ability to, I forget what they call it, but
the stall detect.
Exactly. There you go. So that's what that other pin is. So I want the stall detect. So I'm going to route that pin. I want the serial communication. So obviously I'll be using that pin.
If I remember correctly, Greg, from reading through because I read through the data sheet on this driver not too long ago, you can get the stall detect information out of the one wire serial IOs. You don't need to route that other pin. And it's really smart. If they're doing the one wire on one of those mode pins, then you can just design your PCB or your whiteboard or whatever connections using the pins that go down as well. So now I'm seeing that it's actually pretty smart. You don't really have to use those vertical pins unless you're retrofitting it into something that was designed to use those as mode pins.
Right, you're exactly right. Yeah, so I'll be snipping these vertical pins off because I'll have traces on my driver board that give me access to all of those.
Yeah, and I think if you check the data sheet, you'll see that you can get that stall detect through the one wire as well.
Yeah, but I don't want to have to pull it. I just want to use.
That's the point.
I just want to use the serial for setting parameters, and then everything else: step, direction, stall.
Greg, do those two pins on the end that go up, the one that has the stall detect pin on it, does that pin also go down, or I suppose?
Yes. Oh yeah. Yeah. No. They all go down.
Oh, okay, great. Yeah, all right.
Yeah,
so that's a nice fix to the standard. You know, the wonderful thing about standards, Greg, is that there's so many to choose from.
Yeah. Yeah. Isn't that nice? But I was tickled when I got this working because what I've decided to do. So my robot uses CAN to communicate amongst all the different processors throughout the robot. But I felt like CAN was overkill for. There's a few processors on the ARM, so I felt like CAN was overkill for that. So I'm going with one wire for that because I don't need speed up the ARM. I'm not passing sensor information through the one wire. I'm just maybe turning something on or off or setting some settings. So I've chose to use one wire. So I had a one wire library running on the SAMD, and then I programmed this little ATtiny to simulate one of my processors that's on the ARM, and it's just running this NeoPixel here just for test purposes. So the yellow wire was the one wire, but then I thought I was bit banging. That library bit bangs Dallas one wire, which is very slow, which means it's going to take a lot of time, not a lot of processing cycles, just a lot of time to bit bang that out. So on this little breakout board is a little 6-pin chip that has I2C on one side and Dallas one wire on the other. So that allowed me to essentially offload all the timing critical aspects of Dallas one wire onto that little chip and use one of the hardware serial ports effectively. They're called SIRCOMs on the SAMD. Use that hardware to communicate to that little chip. It also kind of serves a double duty because my one wire bus is 5 volts and the SAMDs all run at 3.3 volts. So it's kind of acting as a level translator as well. So
can you share where you got that little guy? That seems like it would be useful.
That little
yeah, maybe you can put the part number or something in the chat.
Yeah.
I'd like to know what it is.
It's part of the reason that I went one wire is because the sensors that I'm using for position sensing, you communicate with them over I2C for setting them up, but they all have the same, you can't change the address. So I was faced with a situation where I want to have 4 of them connected to my processor, but I can't address them individually. So I started looking at different options. Somebody's got a chip out there that actually does I2C address translation on the fly, but it's like $4 or $5 a chip. So I didn't want to go that route if I didn't have to. I could do multiple I2C buses, either connecting all of them to the processor, or there are chips out there that are like a I2C multiplexer. But then that would have meant I would have effectively 4 I2C buses running up the arm, and I don't like having lots of wires. So I nixed that idea and decided to use a little ATtiny as like a 1-wire to I2C bridge. The challenge there was you can find lots of libraries that do 1-wire master. It's much more difficult to find a 1-wire slave library. I did find somebody's library, and it was designed to run on an ATtiny, but it used interrupt. It used the interrupt pin, which on the ATtiny 25, 45, 85 is the same one of the I2C pins. So then I looked at the library and said, well, maybe I can change it from using the interrupt 0 to make it a pin change interrupt. But the library was so many files and so many lines of code that I quickly abandoned that idea, and then effectively wrote my own 1-wire slave library to run on the ATtiny. So there were a number of days spent creating that library, but it appears to be working. That's what's running on that little ATtiny. So I'm pleased with that outcome.
I ran into something like that working with the Dynamixel servos, where there was all kinds of code for the Arduino to control a Dynamixel. But what we wanted was to be able to put an Arduino on the Dynamixel bus so that we could control the Arduino and have it do relays and other stuff.
Just another node.
As another node, yeah. So I had to write that code. It's on GitHub. Nobody started it. That's the way it goes.
Hello. Hello, community. This is Jason. I've never actually been on one of these phone calls before.
Cool. Welcome, Jason.
Welcome.
Thank you. I was at my local makerspace about a year ago, and they mentioned the Robotics Society might be a place to trade ideas about FPGAs. So I decided to join, and here I am today. I'm no longer active with FPGAs, but if it's something that a lot of people have interest in, I can jump back into that, and we can trade ideas and that sort of thing related to FPGAs.
So our robot arm uses FPGAs extensively. The Dexter from Haddington Dynamics.
Okay.
Ooh.
If you're, are we allowed to job shop here? If you're looking for work, hit us up.
Okay. Okay. I'm not currently looking for a job. I'm actually, that's the reason I'm not currently active in the FPGA, but it might be something I might get back into at some point here.
Well, the thing is, it used to be open source. We were acquired by a megacorp, but all of the stuff that was open source is still out there. It's still open source. It's still on GitHub. And so there's a lot of there's a lot of opportunity for people who know something about FPGAs to get in there and expand on what we've expand on what we were able to publish before we had to go dark.
Okay.
Anyway, I'm always looking for FPGA people. I think it's good to stay in touch.
Good. So I'm not active in that, but if there seems to be interest, I can jump back in and help out, or I may, if I jump in, I'll probably have questions myself. My activities are mostly with Zinc and the Snickerdoodle out there, which came out many years ago. Also, I was working with Blue Spec for doing some of the designs, that sort of thing. The other thing is I have a lot of electronics equipment, or at least more than I'm using for sure, that I've accumulated over the years, but I'm trying to downsize my life. So at some point I may be looking to rehome some of the things I have, inductors, meters, things like that sort of thing. So if there's interest out there, is there a place where we'd find people in the community that might be interested in other equipment?
So we have a groups.io list that you could post that kind of information, maybe, try to make direct contact with people and then work out some arrangement to meet up, let's say, to, swap gear or just deliver stuff. Our meetings normally we're open for that. People were bringing stuff all the time that they wanted to rehome. So when we get back to physical meetings again, then obviously we would encourage that. But in the meantime, go to the groups.io, and so you can go to our homepage, and over on the left sidebar, the contact us link. You just scroll down that page, and you'll find how to join up that list. Very easy, and post your list on there, and have people request that people just contact you directly.
So the homepage, that's not the meetup page. That's another page.
Correct. So SeattleRobotics.org.
Okay, sounds good.
Yep.
Thank you.
Yeah, thanks, Jason. Well, let's see. I've been popping in on the DPRG there from time to time here to see what's happening, and let's see what they're doing now. Oh. So let's see here.
Looks like they're having lunch.
Yeah. Okay, you all seeing my screen there? With you can see the two lower left there appear to be their cameras. I'll just I'll mute mine. Let's see here. How do I do that? Looks like I got my microphone muted. Oh, there we go. Minimize. There we go. Yeah, it looks like they're kind of what's probably going to be the best way to plug into this is to just log into the link yourself. So let's see. I think it was in the chat there up a ways. There was I think probably up near the top. Yeah, the DPRG RoboColumbus competition 2021. And then if you scroll down about 3/4 of the way down the page, they talk about the Google Meet, and there's a link in there. And then just open that link, and that will put you to what you're seeing on my screen here. And it kind of looks like, I think, according to their schedule, well, it looks like more people are joining in here. Looks like it's wonder if there's a way to oh, there we go. Okay. Yeah, okay. So there is a way to kind of pin individuals. Let's see.
We have that.
How did I get you in here? Let's see. Oh, there we go. Well, they got somebody on there that's trying to kind of crack the whip under these guys, you know, get them to like, okay, we're not here to eat, we're here to run robots. I can kind of envision, you know, it's not unlike some of our Robothons where sometimes it can take us a little while to sort of get rolling, you know, you put out a schedule and then you kind of weave and wind your way down the schedule and eventually you get there. Well, I'm going to stop sharing there for a minute since they're not really doing anything terribly interesting just yet. So, but that page there's got kind of got their plan. So it looks like they're figuring. Let's see, 12. They're 2 hours ahead of us. So 11:30, 12:30. So actually, they are. Yeah, they're running a little late on their lunch there from the sounds of it, from the looks of it. So they were planning on doing that quite a bit before this, but anybody else get anything that's just burning a hole in your whatever there to share? Well, we're all still together yet here. Looks like there's quite a few.
I hear that Greg has a live demo of a PCB cutter that he wants to share with us.
Now you're going to get me freaking out here. I'm thinking, whoa, wait a second. Didn't we just do something like that? Is this a recording? Whoa, 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 my brain's going to blow up here in a sec.
The opportunity for something to go wrong is so great that I'm dying to see it. That's all I can say.
Yeah, yeah.
Okay, Greg, if you don't want to do it publicly, can you do a video call with me after this call so that I can watch you test it out?
But if it's going to do something really spectacular, we all kind of like to see that, you know, particularly if there's a lot of flames and bright, colory stuff flying around.
Exactly. I'm thinking, you know, like little pieces of the cutoff disc coming off and, you know, blood and gore. There's opportunities for everything here.
Oh, man. Yeah, we wouldn't want to miss that. Be sure, well, if you do that, be sure to record it, man. We're going to want to see that.
Well, I mean, I think really the only opportunity is I'm going to break the abrasive disc.
Well, but it's what happens after the disc break that breaks that's interesting, because typically when it breaks, then it grabs into the part, and then you get, you know, the part being thrown or the mount breaking or the bearing
Yeah.
coming loose in the cutter. There's all sort of fun things that can happen.
So is that why these are a good idea?
Safety third, buddy. Safety third.
Yeah, yeah.
Okay. I mean, you asked for it. Don't blame me if you wait, what? Huh? Oh, hold on. Gotta turn off the virtual background.
Yeah, you vanished.
Yeah, you vanished. Okay. I get my precious stuff out of the way.
Now the question is, do you have enough hands to operate this?
Okie. Well, first test. Yeah. Okay, that test was successful. The challenge here is I gotta reach around the camera. Okay, where do I want to do my first cut? That's the question. The only problem with this design is I can't really do plunge cuts, right? I can only go all the way across the board.
Oh yeah.
So I think what I'm going to do is go right down that gap and it's effectively cut it in half. Okay, here goes nothing.
Wow.
Woo-hoo!
Awesome.
Worked very
The disc
nicely.
didn't shatter.
Check that out.
Yeah. Nice.
Very
Clean.
very nice cut.
Yeah.
Oh, you know, the other thing is that just to keep safety third is you should probably be careful about particulates here. We don't want you to breathe in the parts from that.
Yep.
Yep. Yeah, don't lick your finger.
And for those that go to a NASCAR race hoping for a crash, I'm sorry I disappointed you. That worked better than I expected.
Wow.
Nicely done. Hey, Greg, I got a suggestion for a new feature for you, because you know feature creep is an important part of any project. How about putting a 110-volt power switch on the little slide there so that you can?
Oh. Yeah. That's not that actually is a good idea. You can just turn it on and off right there.
Yeah.
Talking about feature creep, though, I was watching Elon Musk did a tour of the SpaceX facility down there. I guess it's on YouTube. I've only watched the beginning of it. It's, I guess, 2.5 hours long. But he was talking about how you need to take things out of your design. And if you are not taking, he says you need to take things out. And if you're not having to put back 10% of the things you took out, you're not taking enough things out. And I thought, you know, I should probably apply that to my robotics efforts and see if there's things I can leave out of my designs. as opposed to just keep adding more things to the design. So yeah.
He actually had like a 5-step process in that I thought was so good. The first one was actually make your requirement less stupid. And the thing was, your requirement is stupid. No matter who gives it to you, like no matter how smart the person is that's giving you, telling you that this is what you need to do in order to, solve your problem or whatever. It's always stupid. Just always pretend that it's stupid, no matter how smart they are, and then go from that. I actually did a Facebook post on this, and I was just looking it up. I'll post my summary of it into the chat because I thought it was just really freaking good. It's cool that you saw that too.
Yeah, and there was an order to those 5 things, and
yes.
he admitted that sometimes he gets them out of order. Case in point, he talked about optimizing a process, the fiberglass mat that goes between the batteries and the floor. That was a bottleneck. So he spent lots of time trying to optimize the process. And then when it wasn't working out well, he asked, why do we have this? And so then he went to, somebody said, oh, it's a safety thing. So he went to the department responsible for battery safety, and they said, no, that's not the purpose. It's a sound dampening thing. So he went to the acoustics department, and they said, oh, no, it's not for sound dampening. It's the safety people say it needs to be there, which also led to him saying all requirements have to have a person's name, not a department. And so then they took 2 cars, took it out in one car, and then put microphones in the 2 cars and drove them around and couldn't tell the difference. So rather than optimize the process that put that in there, he realized he should have gone back a couple steps to the earlier steps where you validate the requirement, and if it's not required, leave it out.
Mm-hmm.
So.
Absolutely loved that. I thought it was brilliant. And I have seen this so many times in business and in my own personal projects that I was gonna like print this out and put it up on the wall, and I forgot to do that. But thank you for bringing it up again, because it was just so. I'll just read through these really quick. Make your requirement less dumb. Your requirements are dumb, no matter who they came from. Make them less dumb. Then number 2 is try very hard to delete the requirement and all of the things needed to meet it entirely. Delete things until you need to add things back in. If you can delete it entirely, your requirement was stupid. Number 3 was simplify to optimize function if you are sure you can't delete it. So it's like you've tried really hard to make this thing go away and you can't. So now just try to simplify it as much as you can. And then number 4 was go faster. If you really have to do it, and it's as simple as it can be, do it as fast as possible. And then number 5 was automate it away, so you don't have to do it anymore. Mm-hmm. Make it something that just happens automatically. So you don't have to think about it. I think those are brilliant.
Yeah. Thanks for posting that in the chat there, James.
I gotta go add that to my website.
In case anybody was trying to write that down because they wanted to remember it, you don't have to. You don't have a. Did anybody post a link to that video, by the way? That might be a good thing to throw that in there too.
Let's see if I can find it. I will. I didn't actually link to the video in my. It's what's the guy's name?
Everyday Astronaut?
That's the guy. Everyday Astronaut. If you look him up, you'll find it.
Oh, okay.
Yeah, I have a whole a beginning engineer's checklist webpage on my site, which is like all of the advice that I've collected over the years from everybody. And some of it's just funny and some of it's good. And
if you go to YouTube and just Google Elon Musk tour, it's the first thing that comes up. It's in 3 parts, spanning little over 2 hours.
Okay, good. Let's see. Is anybody on the DPRG thing there? So they getting any further along? Let's see here. Looks like I see a guy's holding a piece of pizza. They're walking around, and then oh, come on, camera focus. There we go. Well, I'm just watching it on my other monitor here, so I would suggest doing the same thing. Just kind of keep it tuned in and see what's going on. Let's see here. I'm
gonna mute while I play with my new toy.
Okay. All right.
More fun to watch Greg cut things than it is to watch a guy walk around with pizza.
I hear you there. And who knows, maybe something exciting will happen, like an explosion. Ooh. That was interesting. Yeah, that seems like a power switch right on the side of his handle there would be really nice. And you could just grab it, maybe squeeze the switch, do his thing, and then let go and act like a dead man switch.
I actually have another suggestion too, which is he's got like that little holder on the left-hand side of the cut to hold down the PCB. You know what I'm saying? Like you see how the PCB kind of goes up under that slot on the left-hand side?
Oh, yeah.
So I'm thinking like extend that to the other side so that the piece that you're cutting off is also being held down a little bit.
Yeah.
For everybody who wants to see the main course thing, enclave on your window as the main screen. Thanks, John.
Okay, let's see.
Because, I don't know if I can do it, but I think, you all can do that. That way you'll get a bigger picture versus the thumbtack type thing.
All right. Let's see.
Out there,
All right, guys, this is it. What you been waiting for? Harold. Okay, Harold. You got into this money.
Does anybody want to take odds on Elon making it to a bipedal robot faster than Boston Dynamics did?
Well, you mean you didn't think that dancer that dancing robot that came up on stage before him wasn't real? Oh, I was sure that had to be. That's what he was presenting.
You know, that was bad even for Elon.
Yeah,
Good Lord.
I
have
know.
I have never seen a single human being that I was more proud of and more ashamed of at the same time.
Oh yeah, yeah. That was and you know I mean people there's been people probably a lot smarter than him and his team that have been trying to create what he is proposing for years and years. You know, it is, I mean, I think he's kind of thinking, well, hey, we've figured out how to make self-driving cars. We'll just take that technology and put it into a robot and we're done. And it's like,
it's for anybody who actually has experience with robotics, because I don't think he really does have experience with robotics. He has experience with a lot of other things.
mm-hmm.
And he's really good at, like, you know, going back to first principles and figuring out how to solve problems.
Mm-hmm.
But he does not understand the extent of the wall that he's about to walk into.
Right.
Is what I would say.
Right.
And honestly, I mean, it's kind of the same thing with the self-driving cars too. I mean, I question his experience with the self-driving cars as well, or his capabilities, because the Google cars, they have been working on those cars for what, coming up on 20 years now, and Thrun and some of the other people who actually know what the heck they're doing are producing cars that are actually level 4 self-driving, and Tesla is not yet at level 4 self-driving.
Right.
I don't know if anybody is aware of it, but in Waymo is the name of the company, and that Waymo is the Google car company. They're owned by Alphabet, and they are actually running full-on driverless level 4 taxi service in Chandler, Arizona. So you can go there and you can sign up with Waymo. You have to sign away your life, and then you can, you know, call for a taxi, and a car comes, and there's no human being on board, and you get in the back, not the front, and there's a divider, and you can't grab the wheel or, you know, slam on the brakes or whatever. You're passive. You're the passenger.
Wow.
And the thing drives you around Chandler and drops you off where you want to be. And if you look that up on YouTube, it's pretty amazing what they're doing. And you can see too, from the information that they're displaying, that all of this stuff that Tesla is going, like, you know, look at how cool we are. Look at what we just got working. This is all stuff that Waymo had working like years ago. So, yeah, Tesla isn't as advanced as they think they are. And then to make this bold statement that they're going to, you know, pivot and make a walking robot.
I thought, sorry, this is Brian, by the way. I'm joining for the first time. But I thought that was more like how Honda back in the day, they did like an Asimo robot as well as a car manufacturing. It was kind of similar concept. It's more for boosting, you know, showing off your technology and whatnot, kind of a thing. That's why I saw it. Not like actually trying to make a robot and sell it as a commercial. I mean, even Boston Dynamics is not selling, you know, Atlas as a commercial robot right now. But,
right.
Yeah, but I would love to see it.
Point. Yeah.
Yeah, I love to see it. Just, you know, I mean, wish him the best. You know, it'll be fun. If it works, it'll be very fun to watch. I don't know how friendly as Elon claims it's gonna be, but it'll still be very entertaining to watch.
Yeah.
I also like the idea that he spec'd it as being weak. Like you can outrun it and you could probably wrestle it and stop it. I thought that was really interesting. I'll be curious to see how he handles the robot not damaging itself and being weak at the same time, because those are, I'm not saying that those are totally mutually exclusive, but usually they are, right? So like if
well,
you
maybe
build
he
a
will use
joint-
like a flexible robotics, you know, like not actually, you know, hard robots like any of the industrial robot or Atlas, but like those like air. There's some lot of research at MIT that does flexible robotics.
Yeah.
You know, maybe I don't know. I mean, if he's claiming that, you know, you could maybe wrestle it, I don't see wrestling with the hard aluminum. I wouldn't like to do that.
Yeah.
Well, so actually, the robotic arm that my company makes it's all hard, but the position sensing in it is so accurate that we can sense forces, deflections, and then we run the motor with the force to get out of its way. So
Like
you can take a
Baxter,
robot arm, yeah,
is
put it in a
similar to,
mode and you
okay.
can just move it wherever you want to. But the issue is that if you make a joint that's tough enough to not be damaged, and then you try to drive that joint in a weak way, it's like the weight that you end up with for it to be tough, then you have to apply so much torque to be able to drive it against gravity that it ends up being too strong when it's coming back down. Does that make sense?
Yeah, I
sure.
mean, I thought though this Elon's claim of like how much mass that this robot can carry wasn't as crazy of a number. Maybe I was wrong, but maybe on the leg side of the torque of the 5 miles per hour to produce that, maybe leg might be more stiffer and stronger, but arm side of things, I thought it could be more soft. I came from a background in human robot collaboration side of research. I was a robotics researcher and then moved out to Seattle. And we did like a similar testing with a industrial robot where there is no safety net in terms of, you know, there's a lot of casualties, actually robot killing humans in the factory that really doesn't get reported as much as it should on the media, you know, given that we're going towards a lot of automation in factories. And but I do see hope. Like I guess I'm being more hopeful here, optimistic. But I do, from like a recent research paper, I think there was a one that was posted in IEEE Industrial Automation and Systems magazine. There was a good research paper about human robot collaboration controller. I think Northeastern University published it. Maybe like your company, since you guys are actually directly working on, might be kind of interesting to read. But the given like a hard robot doing soft touchness have been software-wise significantly improved with this algorithm. I didn't really like a read in depth towards the algorithm side of things, but that's what I've heard. I don't know if that claim was true, but it was, you know, posted on the IEEE magazine, so I guess it may be. Oh, look at that robot crawling. So what's this competitions of is this a competition or?
Steve, you're muted.
Yeah, sorry about that. You guys probably didn't hear anything that I just been saying. So for some reason it looks like the feed from the guy that was following the robot there dropped off, and I'm not seeing any. If you can see there in the tiles on the side, it doesn't seem to be any video from anything active at the moment. So the RoboColumbus competition is based on our RoboMagellan competition that the SRS created a bunch of years ago, and we were routinely doing those at our annual Robothon events. And it's an outdoor navigation challenge. So the goal is to create a robot that can find orange traffic cones outside and follow, essentially get to them, touch them, reorient itself, try to find the next one. And it's a very difficult, it's actually a very difficult challenge to do. And people have been trying for years, and it's just to get to a cone is actually a pretty major accomplishment. These guys, I'm not sure if this RoboColumbus is a first shot at them doing this, or if they've done like some sort of a RoboMagellan type thing in the past. But this is I believe this is their version of this contest, which I think is pretty much the same. The page there I think talks about kind of the basic competition, and there's usually time involved. You get multiple tries. Your robot gets like 3 attempts to try to complete something, and then you get so many points if you can find each respective target. And then
All right, this is Skipper.
Okay.
I named him after Don. He does differential steering. He's got camera, wheel odometry, gyro. Now I have an aim at the phone. I'm going to turn it on. It'll drive straight there. And 3, 2, 1.
Ooh, I like how it slid down that slope.
Yeah. One of the, pretty much everybody uses GPS in one form or another, along with some kind of vision. But the problem is, though, that in the outdoors, detecting colors reliably with a camera is a challenge because things look different. Our eyes are able to adapt to that quite readily, but it's much more of a challenge to give a robot that kind of flexibility. And so it's very easy for the robot to mistake, for example, somebody standing around who has a bright colored coat or pants or something. And robots often mistake people for the traffic cones. That's been our experience. They don't have that disadvantage because it looks like it's a pretty deserted place that they're operating. So that's good. The Seattle Center in downtown Seattle is usually surrounded by people, and so that's an added challenge that we have with our competition that others may not or can eliminate by picking a remote location. Okay, it looks like he went out of range too. It's like they need to keep their camera a little closer to their Wi-Fi and just zoom, get a camera with zoom on it or something.
I do like the idea of doing an outdoor competition because it's a heck of a lot safer, during this pandemic.
Yep. Yeah, and it's a much more feasible event to pull off too. Yeah. And of course, in Dallas, they can pretty much count on nice weather too. Up here in the Puget Sound, it's hard to know whether you're going to get sun or rain or overcast or whatnot. And and depending upon those lighting conditions, what the camera sees will be different. So it's like you almost need to have some way to calibrate your camera based on the actual conditions. Okay, looks like that camera dropped off. So
Yeah, what you were saying about vision is really true. I think one of the things that's kind of always bothered me about robotics is that people think that things are easy to do because a human being can do them easily.
Right.
And there's two problems with that. The first one is it's wrong.
Yeah.
The second one is that people don't take the time to appreciate how that points out how truly wonderful our bodies and minds are.
Right.
Right. Like all of these people invested in big startups, you know, before the first AI winter, you know, thinking that like we're gonna have robots walking around doing jobs in the factories and stuff, and totally didn't get how difficult walking really is. And then when it didn't work, they were all upset. You're like, I want my robot kind of thing. And nobody was like, wow, this is really cool. Thank you for pointing out how wonderful we are.
Yeah. Yeah.
My only complaint about the Robo Magellan contest is because of the way that it's laid out, you have to have a cross-country robot. I would like to see a Robo Magellan that's intended for wheelchair accessible terrain.
Oh, like a parking lot or something.
Yeah, or I mean, you can do it at Seattle Center because there's you know, asphalt and concrete paths, but you know, I don't know that, you know, if what we're trying to do is demonstrate that we can accomplish tasks that robots will need to accomplish, you know, in the near or far term, being able to navigate in an open field, I don't know that that's as significant as being able to navigate on a sidewalk.
Well, and more than that, like you said, it just cuts out all of the people who have a robot base that can't handle like grass or, you know, dirt or whatever.
Right.
Yeah.
Yeah, I agree. If you're going to do this, I would do it like in a parking lot or in a, you know, some place that has sidewalks or something that are fairly smooth. There's one of the big universities, and I don't remember which one it is, does a line following robot thing down a sidewalk every year, or at least they did do it every year for a long time. And it's a sidewalk where there's like ramps and they put up like these little hoops that you're supposed to drive through, and the lines cross each other and all that kind of stuff. I was trying to figure out which one it was.
Are you talking about DuckyBot, like small robots with like a crosswalk? Maybe it's that one you're talking about.
Well, it was on a sidewalk, and then they were all line follower robots. They weren't really.
When they go far out like that. Yeah, I was looking at. Or did Clay lose his video?
Clay and Larry have been broadcasting video, but as they get farther out towards the first target, they drop out.
And they come back in, maybe. Okay. I don't know if moving the computer will help, or I'll see if moving this out a little bit. I'll try that.
Yeah, I think it's whatever Wi-Fi they're connecting to with their phones.
Yeah. Good. I'm glad somebody noticed that.
See if I can move this camera out a little bit so you get more of that.
Seems like what they ought to do is just get a long extension cord and put their Wi-Fi hotspot way out there.
Internet connection as I go down the hill, and it's also overheating. So I'm trying to reconnect as well as I can.
I appreciate everything you're doing, and it's good to watch.
Yeah.
And on the other end, there's about 5 people with GoPros and cameras, and there's a drone. So there will be footage, not live, but after the fact.
Ah.
That's fantastic.
Okay. I'm thinking, for purposes of our recording, I think maybe I don't know, we could probably shut it off pretty close here. I mean, it will be possible to go to their website and obviously get, you know, more complete video from a variety of different sources from the sounds of it. So there's really no value in our double recording what they're already recording. But any other questions or comments? I do like your idea about maybe considering doing something maybe more on a hard surface. That's certainly an option if there's a place where we can do that. I mean, Seattle Center, it turns out, has this big grassy area to the south side of the Armory, which has been a convenient place to do this, but they don't. Short of a parking lot somewhere, they don't really have any large open paved areas that I can think of.
Does it really have to be a large open area? Can't it be like winding around sidewalks and stuff?
Yeah, it's more in the case of the Seattle Center, it's more a matter of an area that we can cordon off.
Right, like getting the permission from them to actually, for them to let you cordon it off. Yeah,
they have to allow it. They have to actually allow us to do that. And we like the venue because there's lots of people that don't normally have any contact with this stuff. So you've got all these people, just the general public, walking around, and many of them never even seen robots before or up close. And here's an opportunity for them to just sort of casually interact with them, and
then you can recruit.
We don't want to do it. We could go to a college campus somewhere and find a big parking lot, but we want people to see what we're doing. We're not just doing it for our own fun. There's a half of this thing is just doing it to just
video back again.
Show what we can do.
You want to narrate and talk about your robot?
So what about doing it in a parking lot at the Seattle Center?
Well, again, it would require getting permission to block off parking lots. The time of year that we typically do these, parking is precious down there. Oh, I like that one. Look at this little robot. That looks like a little tractor. That's awesome, except he's going backwards.
In Clay's video, we can see it working now. And the other stuff is pretty far away from your camera, John.
Yeah, that's about as close as I can get there. So hopefully, at least Clay's better. But I'll aim it for cone number 2 in that case.
Okay.
So that's number 1. It sounds like number 1. Well, there's.
I can't quite tell, but are the back wheels on that? Do they have a suspension on them?
Great, thank you.
Should be in the middle of the pit. Okay.
Is that the John Deere entry?
Yeah, I think that's what I was thinking.
Guys, it got to the cone, but sort of around the cone, but wasn't able to see it. So the first run was a bust for me, anyway.
Huh. It looks like we lost something from them. Not getting any audio at the moment, and doesn't look like any of the video is doing anything right now either. So. We've had this talk too about possibilities of like some sort of an indoor thing, although the navigation becomes a little more challenging because your GPS isn't going to be terribly accurate anyway, but it gets a little worse when you start trying to move indoors, even if you can actually get some satellite signals through a ceiling of your venue. The indoor navigation systems are out there. There's technology to do it.
There's a local group here in San Diego that does the mule cars, I think they call them, which are self-driving cars. They have like a racetrack that they lay down. It's printed on vinyl or something, and they lay it down on the floor, and then the cars are supposed to follow that racetrack using vision. It's a fun little donkey cars, they're called, now that I'm thinking about it. There's been some fun stuff that's come out of that. One of them was a guy that I know got his car all trained up to where it was working really good. And then they moved the track to a different venue, and his car just went nuts and couldn't follow the track at all. He was trying to figure out what was going on, and eventually realized that his camera was seeing not only the track, but also the room above and around the track. And so his car had learned to turn left when it saw that window, and to turn right when it saw that electrical box, which was a part of the old facility. And when they went to the new facility, of course, none of those features were there on the walls of the building. So it just went crazy.
Just a video here transferring virtual computer goodness out of the garage. I love it.
Yeah, so
little garage cleaning there at home, Richard.
I moved out about 200 cubic feet of computers.
Holy moly!
Thanks to someone in Seattle at the Seattle Retro Computer Group.
Are these all old computers, like historically old?
Yeah, like nothing newer than 1990. Most of it's early 1980s.
Oh, wow.
What did you do with that stuff? Who took it?
One of the Seattle Living Computer Museum guys took it, and John Dersh. Josh Dersh.
And your wife thanked him profusely?
Yeah, we both did. Because I've moved this stuff around a lot. I have not had the time myself to do anything with it for about 20 years. So, things like those SGI desk side units.
Oh, wow, look at that. Yeah.
Oh, that's awesome.
The newest thing in there was a Tadpole Sparkbook. So it's a little 110 megahertz laptop with a MicroSpark 2 processor running Solaris. And that was probably the newest computer in that load.
I was looking at this. What's it called? It's basically an Altair recreation that runs on an Arduino.
Mm-hmm.
There's kits available for that, and they look really nice. It looks like kind of a miniaturized version of the old Altair S100 computer front panel, and then it's basically got an Arduino inside that's running an emulator. And I was trying to convince my wife to let me hang one on a wall and then use it for like home automation and stuff. And there was some fairly loud arguing for a while, and then I gave up on it. Probably for the best. Nobody else in the house would appreciate it the way I would.
Yeah, that's kind of where I was at too. It's like, there's nothing I can do with this stuff really, other than get rid of it at this point.
Unfortunately, I can see where this needs to be on the takeout on the drone. Oh.
Yeah, I think, Richard, I think the best part of this video is your son on the various little vehicles there.
Right.
Back and forth across the garage, the bicycle. I mean, he's awesome. Oh, that is great. Thank you for sharing that. That's cool.
Yeah, the next one there is actually one of the SRS ones.
Let's see, this CD robot.
Yeah.
Looks like a pretty short one. Yeah, I'll go ahead and play it. What the heck? Let's see here.
Ancient stuff. Looks like 13 years ago now. probably turn that thing back on and see what state it's in.
Oh yeah, there's actually it looks like there's a lot of SRS videos. There's another one there.
Yeah, yeah.
Yeah,
I was doing all those surface mount soldering kits for you, so I had to make videos showing, you know.
Right,
what things do.
right. Well, I think I'm going to go ahead and stop sharing. The link is in there. So if you want to join in the DPRG folks and continue monitoring that, it seems like something you might need to just sort of turn it on and check in on it now and then, you know, because I mean, it's I have a feeling they're going to be doing that all afternoon. But thank you, everybody, for coming to the meeting today and sharing and being a part of this.
I think Greg deserves a special thanks for allowing us to bully him into trying out his PC board cutter.
Yeah. Thank you, Greg. It was awesome.
Yeah, you're welcome.
Yeah.
I want you to know that we all appreciate it, even if no actual blood was spilled.
I know.
Well, I will tell you though that I stopped cutting boards because the other end of the flexible thing seized up.
Oops.
So wait, you're saying the flexible drive for the cutter failed?
Yes.
Oh wow.
Was
it clamped in too tight or something, or was it just failed on its own?
It has some spring clips, one to hold the bearing into the outer shell, and the other to hold the kind of the spindle or the shaft in the bearing. And I think those two spring clips interacted with each other and bound up.
Oh no.
Wow.
Yeah. So anyway, not the best design.
You know, engineering is full of challenges. Now you got another one.
Yep.
All right. Well, thank you, everybody, and have a great day.
Thank
you.